This video is part 3 to chapter 4.2, algorithms for the multiplication of whole numbers. And so similar to addition and subtraction, we are all familiar with what we call the standard algorithm. And so the standard algorithm would follow this format right here, this kind of vertical format, right? The standard algorithm, 213 times 3. What we're looking at is you do 3 times 3 is 9. 3 times 1 is 3 times 1 is 3, carry the 0. But really what's happening in your head, you got to think about it's really 3 times 10. And then why do we put 2 zeros down there? Because you're really doing 3 times 2, which is 6. And so really what's happening here, kind of underlying the standard algorithm is distributive property. So you can see distributive property here when you see 3 times 3 is 9, 3 times 10 is 30, 3 times 200 is 600, and then you add them together and give you 639. That's what we call that standard algorithm as we learn to do that. And there's, again, you can see it right here. This would be a horizontal format if you wanted to see break that 213 up into 3 pieces, distribute, you get an answer. That would be horizontal, but you can see it seems to be a lot more writing, and so the vertical format seems to have an advantage. However, it's important to recognize that you understand this part right here, right? That it really is from distributive property. Now that leads us to alternative strategies to multiply. So let's take a look here. Next, the product of a 2-digit times a 2-digit, 34 times 12. You could see it as 34 times 10 plus 34 times 2. With our number talks, hopefully we've been emphasizing these techniques so you can see these alternative strategies to do that. And you end up with your 408 still. And you still might say, I'd rather just do the horizontal format using a standard approach, which is fine. Again, you just want to be aware and be flexible with your thinking, because sometimes it's easier to mentally solve it in this manner using kind of this distributive property approach. Another representation is kind of this, what we do in algebra when we do these kind of factors. Sometimes people show how to do it with rectangles. And so in this case, 23 times 16, I'll recreate it here. So you end up with a rectangle, and there's 23 there, so you break it up into pieces. There's 20 plus 3, here's 10 plus 6, and then what you do is you kind of use what we call an area model. This is very similar to an array or area model. 20 times 10 is 200, 20 times 6 is 120, 3 times 10 is 30, 3 times 6 is 18. Now it's a lot of work, but you can now see kind of what that value would be when you add that all up together. You get 368 when you kind of put all that math together there, and that's an area model. And so there's also models called intermediate models. We saw this 34 times 12. Is that the one we did up here? No, 213. 34 times 12, right? 4 times, here's the standard. 4 times 2 is 8. 2 times 3 is 6. Place value 0. 1 times 4 is 4. 1 times 3 is 3. And then you add up to get 408. Other ways to think about this in an intermediate, kind of an in-between way, hence that word intermediate, you can then see 4 times, we can think 2 times 34, and then 10 times 34. Really what's going on is distributive property. You may also see it here. 2 times 4 is 8 right here. So this would be 2 times 4. Where's the 60 come from? Because it's 2 times 30. Where's the 40 come from? Because it's 10 times 4, and the 300 is 10 times 30. So you can see those numbers then come from there too. And again, that would be kind of like a distributive property issue there. And so you have these what we call intermediate algorithms. You can see this example here, so that when you have to do for homework, you have some examples here to help you with that. The other piece, we can do this one here. Let's do this 34 times 12, which we know is 408. Using this lattice method, it looks like a lot of numbers. Let me create one, an extra example, 34 times 12. So 34 times 12, we already know equals 408. Let's do a simple lattice example, right? And so in these cases here, what happens is you end up drawing, it's kind of similar to an area model. What you end up doing is, here's your 34, here's your 12, and in each location you have these, what we call lattice. And then you have 4 times 1 is 0, 4. 4 times 2 is 0, 8. 3 times 1 is 0, 3. 3 times 2 is 0, 6. And so you just put those answers in there, and then you add diagonally again. So this would be an 8. 4 plus 6 is 10. Carry the 1 because we're adding diagonally. 1 plus 3 is 4. And so then there's your answer, 408. And so there's a situation here. So what you see here, it represented here, is 4967 times 35. 4967, 35. Draw your rectangles or lattice. And you can see, just multiply and fill in your 2 digits. And then what happens is, I know this answer is 173845 because it's going to be those numbers there as we add diagonally here, as you start to add in this way to get your answers there. And then you can multiply using what's called the lattice method. If I were you, I would try to make up some of your own, just practice one, or just do the homework and see where those problems that say lattice method. So those are algorithms for multiplication.